EES, which is pronounced ease, is an acronym for Engineering Equation Solver. The previous sections described how to create and modify a plot. This video we're going to talk about some of the more advanced features of plots in ease. So let's start with the same system of equations here and create a parametric table. In this time we'll include x and z. So we'll vary the values of x here and run the table, and you can see z is filled in, and we're going to make a plot of z as a function of x. So if x and or z have some uncertainty in their values, maybe due to experimental uncertainty or for other reasons, we may want to plot them with some kind of error bars, and ease lets you do that. If we right click on the plot, we get back to this modify plot dialog. And down here you can see the error bars option. So if we select y-axis, you're going to bring up the specify error bar information dialog that's shown here. And you can see there's 3 different ways that we can set the error bars. We can set an absolute uncertainty. So here let's set an absolute uncertainty of 0.2 for y. And we'll repeat the process for x. In this case maybe 0.5. And you can see the result here. We have a plot now where there's constant size error bars on every data point. We can alternatively use a relative uncertainty. So here let's go back in, and I will set the size of the y error bars to be a constant fraction of the y values. And you can see the result here. Finally, the uncertainty values used to generate the error bars can be obtained from a table. And this is particularly handy if the errors have been previously calculated for each of the runs, maybe by some kind of an uncertainty propagation calculation. There is a built-in uncertainty propagation feature in ease, which is discussed in chapter 8 of Mastering Ease. But here let's just create a lookup table, and we'll enter some values for the y error bars. And then once we've done that, we'll go back and select set uncertainty to values in table, and we'll navigate to the correct table. And now every run in the table will contain the error bar that will be used for the associated row or data point in the plot, and you can see that here. It's also possible to generate asymmetric error bars, so maybe the upper error is different than the lower error. So you deselect the identical upper and lower values here, and that brings up a separate window where you can now independently select the upper and the lower uncertainty values as shown here. So maybe I can set the upper error to 0.5 and the lower error to 0.1, and I get these sort of offset error bars. In the last video we talked about both adding text to a plot and also about the automatic update feature. And these two features in combination can lead to some problems if I'm using text to label a curve, and then due to the automatic update feature the curve moves around. So for example here, let's label this curve directly as z variable, and we'll move the text to a convenient place that's right next to the curve. And then we'll check the auto update option. So now the plot itself will change as the data in the parametric table changes. So let's go back to the equations window, and we'll change one of these coefficients in our equations. Run the table again, and when I go back now to the plot, you can see that the curve is moved right into the text because the text itself didn't move. So I can fix this by linking the text to a data point in the plot. So here I'm going to link the text to the third data point, and we'll offset it in the x a little bit. And now if I reset the coefficient and run the data table again, you'll see that both the plot and the text move together, which is really pretty convenient. There's some other useful features that you can find here in the text tool. One is that I can put not only just text on the plot, but I can actually put the value of some variable in the ease program right there on the plot. So here, let's go back and make this coefficient a variable c, and we'll set c equal to 2. And now I can select ease variable in the text tool, and the value of that variable c is going to be placed right on the plot. So I will always know what value of c was used to make this plot. Or alternatively, I can check update, and you can see that then the value of C will always be updated every time it changes in the program. There's this integral button, so the integral option automatically displays the integral of one of the data series on the plot. So in this case we have only one data series, and if I press this, you'll see the integral of the variable z with respect to x, which is I guess the area under the curve, then will be displayed on the plot, and that integral value will automatically update if I change the data in the table. Note that strings of international characters can also be displayed on plots, and you enter those strings directly in the text box, and these will automatically detect if the entered text contains international characters, and if so, a blue international characters in use message is going to appear under the plot. When the plot toolbar is visible, you can also copy graphic objects from other applications. So here I've opened up PowerPoint, and I have a graphic object here in PowerPoint. I can copy it, and I can bring it over and paste it right into the plot window. And then if I right click on it or any of the graphic objects on the plot, I can change its properties, and so in this case I'm just going to change its size so that it's a little more convenient. There's a couple more useful tools here on the toolbar palette. The crosshairs tool brings up a status bar at the bottom of the plot that shows the X and Y coordinates of the cursor. So if you're interested in putting the cursor on a certain data point, then down at the bottom you'll see the X and Y values of that data point. The plot is normally locked into position in the plot window, so you can't move it. But if you want to move it, you can use the Move Plot Tool button right here, or you can actually just hold down the Control key and you can move the plot. And that's really useful if you find that the plot's located too close to the left or the top of the plot window. And then finally there's this Zoom tool here, which basically allows you to zoom in on a particular region of the plot. So I can draw a rectangular region here, and what happens then is a new plot is created, and that new plot just shows what was in that rectangular region, and that's nice if you want to see something more clearly. So this is one of a series of tutorials meant to describe the operation of the EASE software. If you want to get more information about EASE, obtain the software, or access more of these tutorials, please go to fchart.com. These tutorials are excerpted from the book Mastering EASE, and that book can also be obtained from the FChart website.